So in this video, I'm going to focus on fundamentalist theorem of calculus. So basically, suppose that if a function f is continuous on a closed interval, so if we just look at this graph, there is a function over here like this, function f. So suppose that f is continuous, so meaning that there's no bound between these two areas, these two intervals. So b. So if f is continuous on a and b, closed interval, it's meaning between these two. So this statement refers to this area, this region, I would say. So if f is continuous on a and b, first of all, so this is used to find the area here, integral a to b f of x, which is equal to antiderivative of f b minus antiderivative of a. So this formula is essentially used to find the area under the curve. So yeah, if you guys just see this one, you will understand this one. If we just take the derivative from this f here, antiderivative, it's gonna give us f. So basically, the integral is an inverse of derivative. That's really important. So second, so we're gonna focus this one. So second, if g of x equals a integral a to x f of t dt. So there is a g of x here, right? Over here. So if g of x exists between a to x, so this x here is not a value, it's just an x between this function, then if we just take a derivative of g of x, it's gonna be equal to f of x. So why, right? So let's quickly prove, let me make a quick proof of this statement. So if we just look at this problem, this statement number 1, and then convert this, it's gonna be f of x over here minus, and the derivative of a, it's gonna be over here, right? So now this is a actually area, right? So now this one is equal to what? G of x. So what do we want to find, right? So we want to find the g prime of x. So which means we're going to take the derivative of this function. So g of x is equal to f prime of x minus f prime of a. So which means what? So a, what is a, right? A is a constant. Therefore, it's gonna be 0. If you just take a derivative of from a constant value, it's gonna be 0, right? If we just take a derivative of 2, it's gonna give us 0, right? So it's gonna give us 0. So we can just ignore this one. Therefore, g prime of x is equal to f prime of x. So what is f prime, right? F prime is equal to f. So if we just look at this one, right? F prime is equal to the original function. Therefore, it's gonna be g prime x is equal to f of x. There we go. So that's how we prove this statement.